Okay, so this video is an addendum to the Unit 3, Lecture 2 on the topic of conditional statements. In our original notes, I had written primitive types here for A, but I should have limited those primitive types to char, byte, short, and int. Any others will cause errors. Decimal types are not allowed, so float and double are out, and the long type is not necessary for doing switch cases. It's too large a number group. You don't need to count that high. And the wrapper classes should be limited to the corresponding primitive type, so character, byte, short, and integer. So again, if something is declared as a double, you should say that is a compile time error, or a long would cause it a compile time error, and that would be the first thing that we should catch and discount. Other than that, out of the reference types, you have the wrapper classes and the string type. Those are all of the reference types you are allowed to use. And just to expand on the item number 2, compile time constants, this means literals, so literal integers, literal strings. You're allowed to use literals, or you're allowed to use variables that are final. Those are considered compile time constants also. And again, the reference types for the switch argument cannot be null. That means up here at this point, if you have a wrapper class type or a string type, it cannot be null. That will cause a runtime error. That means it will compile fine, but then when you go to run it, it will cause an error. So just to make sure that we look at an example that addresses these new rules that we're talking about in this addendum, notice here that the variable x is a double, and then x is used in the switch case. Right away, we should say this is not going to compile. We know it's going to be the answer D, a compile time error. However, if you change that double to be an int, and you change all of these to be integer literals, then it would compile fine, and this would print out x is equal to 1.0. So again, by immediately noticing this is a double, we know we can say this will not compile. That's the correct answer. But if we consider the case that we're an integer, then A would be the answer. And this image here just shows us that the BlueJ compiler shows us we have an incompatible type, and it highlights the double inside the switch statement. One more topic I'd like to throw in here are nested ternary constructs. In our original notes, we talked about ternary constructs. Ternary constructs started with a data type, a variable name, set equal to, and then we had a conditional followed by a question mark, and then the result if the conditional was true, followed by a colon, and then the result if the conditional was false. But just like for loops and while loops and if statements could have nested versions of each other, ifs inside of ifs, whiles inside of whiles, the same is true for ternary constructs, and the OCA exam does test you on them. So how do we address this? Very similar to what we did with if-else statements. When they didn't use braces or proper indentation, we worked our way from the inner pair of if-else statements outwards. Just like we said with mathematics and PEMDAS, we do parentheses from the innermost set of parentheses outwards, and that's what we should do here. So we begin by locating the question marks, and we say we have two conditionals. Let's start with the innermost conditional, and that innermost conditional should have a true false that gets paired with it, and we see that that's our first set. We want those all paired together. Then we go out to the next step, and we say, all right, here's our next conditional here, and that's going to be paired up with this as a false statement on the other end, and the true statement is the one that follows immediately after it. So again, we have our conditional, our true, and our false. And then here, this inner one, we have our conditional, our true, and our false. So when we go back to evaluate this, we say, well, price is 50. That is greater than 45. It's true. So here's the true. Let's look at quantity. Quantity is 4. That is not greater than 6. It's false. So this will print out 42.5. So take a moment, look at example 2, see if you can figure it out. This one has 3 question marks. Remember, start from your innermost and work your way out. Pause the video here, unpause to see the answer. So here are our question marks. I'm going to start from my innermost conditional. And then I say, great, those three go together. Let me go to the next conditional. So that means this B greater than C has a true result here and a false result here. So these three go together. There's the conditional, there's the true, there's the false. And then here is our outermost conditional, and that's going to get paired up with the false on the end. So there's our conditional, there's our false, and our true statement will be this next statement after it, which is another conditional. Now we're ready to go and evaluate everything. The first statement says A is less than B, A is 5, B is 4. That's false. So we're just going to go to the end and say this is going to print out 40. But what if that statement was true? If it were true, then we would go to B is greater than C, and we see, well, B is not greater than C, it's false. If it were true, it would print 10, but since it's false, it will run the next conditional, C less than A. And we say, well, is C less than A? No, that's false, so it would print 30. So again, if the A less than B were true, then the result would have gone through the next two conditionals and printed 30. So again, the strategy is find all your conditionals, start from the innermost group of three, because ternary operators are groups of three. There's the conditional, the true, and the false, and then we work our way outside to pair everything up properly so we can evaluate it. So we have some practice problems to look at. Here's question 1. Submit your answer, and then you'll see the result. So we see that this is a double value. Since it's a double value, we know that this code will not compile. I have no reason to do any more analysis, and I can say that the answer is D. Practice problem number 2. Read through it, evaluate it, submit your answer, and then watch the solution. So we see that this is a type byte of a wrapper class. That's fine. It's not set to null, so there will be no runtime error. It is set to 0. We go into the switch statement, and the double plus says to update the count variable first, then compare it to everything else. So now count goes from 0 to 1, and we say case 1 is true. It's going to print byte 1. But there's no break statement, so it's going to print byte 2. But there's no break statement, so it's going to print byte 3, and also no byte. So your answer here should be E, byte 1, byte 2, byte 3, no byte. And here's practice problem number 3. This uses a nested ternary operator. Submit your answer, and then watch the solution. So here we see there's a bunch of integer variables that are declared and set equal. And we look at the ternary operator and we see there's 1, 2, 3 question marks. And we want to start from the innermost conditional statement here and take its next 2 terms, because the ternary has 3 terms. So we have our conditional, our result if true, and our result if false. And then we say, all right, the next one here, that conditional, if it is true, it will pair up with the conditional inside, and if it is false, it will pair up with 100. And then we go to our outermost conditional statement, which is going to get paired up with the 110, and if that is true, it will run the conditional next to it. If it is false, it'll go right to the 110. So what is printed as a result of executing this code? We see that S1 is less than S2. Well, that's true. So now it's going to evaluate S3 is greater than S2. That is also true. So now it's going to evaluate S3 is less than S1. That is false. So it's going to skip over this and evaluate this third one. So we're going to do 2 times S1, which is 90, plus S2, which is 120, plus S3, which is 150. And then we're going to divide all of that by 3. So we have 180 plus 120 plus 150 divided by 3, which gives us 450 divided by 3, which is 150. And that is answer E, And that is the answer to this practice problem. This is the end of this lecture. So you should go practice some of this coding in BlueJ, make up some of your own tasks. Make sure you understand the switch operator and the ternary operator when it's nested. And these topics will be on the M3 assessment for marking period 3. So you need to know how to do these to answer those questions that show up. All right, good luck.